All right, welcome everyone to another XAFers community stand-up. Today we're going to be talking about Azure OpenAI and how you can use it to prototype your next XAF app and your next big idea. As always, thank you for coming. We are really excited with the AI revolution that is happening right now. Everyone talks about AI, but it's also good to know what AI is, what is happening under the hood, how can we leverage for the line of business application that we always build with XAF. So as always, join our Facebook group. We are already 3,600 members. So really excited to see the community grow. Hoche, I will let you introduce yourself and then we get started.
Okay, so hi, I'm Hoche. I guess everyone, at least in the group, know me. I work for Sari and Big Frameworks, and I'm in charge of research and development. And I try to share everything that we get as interesting point in the office.
Perfect. All right. Okay, so let's get to it. Let's do it. Like we like code more, but we'll do a quick PowerPoint talking about AI just to mention what, especially what people think about AI when they hear the term, or when they use ChatGPT, when they are actually thinking of, okay, let's build an application that use AI tools to solve any issue. So the first thing that we want to mention is there is a lot of terms that we have nowadays about AI, AGI, generative AI. So basically, let's make them more accessible for everyone. AI is just the idea of making a machine capable of performing tasks that basically require human intelligence. And general AI basically is a broader term like AI designed to learn and perform at human's level. And generative AI, that's the one that we want to talk, that's the one that everyone is using in ChatGPT, is an AI model that is capable of generating text, image, or other media. So if you see ChatGPT that generates text, DALL-E that generates image, there is also speech to text, text to speech. There are a lot of video generation, video edition. So all of those things, so that's the generative part, making sure that a model is able to get trained and produce any type of output in the manner of text, image, or other media. So basically, everyone thinks of AI about magic, but the real thing is it's not that smart. It's just learning from their trained data and producing some output from it. So if we think about the AI of the movie, that doesn't exist. It's not like the AI have some actually reasoning behind. It's not that AI actually have feelings and that. A good example is the iRobot movie where the robot goes to the lake. I don't recall exactly the scene, but he's going to save a kid and an old man. And he saved the old man because he has more probability, has more percentage of success. That will never be the case of a human. So human will always save the child that is the one who is starting to live, is the one that the old grown-up person, him probably will be able to save themselves. So that worry that people have that AI will replace us, that's not going to happen. AI is a really great tool that we can leverage in our code. I don't know if you guys are using GitHub Copilot or any other of those very tools that we have over there. They definitely make your life, your coding life a lot better. But that's it. It's just a tool that we want to use. So the other big term that we have is LLM. And basically here we're talking about large language model. And this is what we use everywhere, that we use these models and we inject huge amount of data, and they are really good for natural language processing tasks. Just summarize, to write about something, to translate. That's one of the original examples. So it's more about a data mimic. It's monkey see, monkey do. So basically the idea here is it will see everything that we're training him for. So it will see that every time that we inject this data and we ask this question, this is the response that we're expecting. And you start learning and learning and learning, and just basically imitate that process. It will imitate those patterns. but that's pretty much it, nothing else. If we now continue, we have the bigger term GPT that we see everywhere, GPT-3, GPT-4, and basically it's generative retraining transformer. And the idea here is to make sure that based on model, it creates text that looks like it was done by a human, that a human can actually produce this text. If you have seen the before text about GPT-2 and even before those, that, yeah, it does produce a lot of text, but it still was not as fluent as it is right now. Right now, you can actually ask him, hey, can you write an apology for my girlfriend because I got home late yesterday, played with my friends, I don't know, in the pool or having something. It will create a really, really decent apology letter, apology text message. Same thing for everything. Like you can actually to help you write emails, to help you your marketing content and so on. So it's getting really good. So the idea here is that these three parts, generative, of course, that's the part that you create all the text and then you pre-train it with those tests. So you can inject huge amount of data, and then the transformer part is like we take that input that you send it and it will transform it and so on. So it will be to voice. So basically that's something that for accessibility, it has been huge and we have all benefit from them. There is all these voice apps right now that are huge that you can order a pizza and you can do anything from your home. That's basically what we are going from here. Image, and if you have seen the image every now and then, they even look better than real life. So level of detail, so level of pixels is just beautiful. How you see that from a text, it goes to the process of the model, do a transformation and do a huge image that we can use in our site and everywhere. So right now, before we have to do this Photoshop of everything, right now I say, okay, I want an image that put a hand tree, a tree on the palm of my hand because I want to show how I'm growing talents and growing things, and like it does it really nice. And of course, this was, I think, one of the first use that was the machine translation. Basically, is taking a text in one language, running through the model, going to transform it another language. So now this is the interesting part. When you ask questions to ChatGPT, or you asking for something like even to complete this or write me an email, seeing how it's doing this so fluent. How is that taking my input and making this amazing content? And it's all, and I'm not a data scientist, we don't know exactly all the deep algorithms that is going on here, but basically what it does is a probability distribution. So all the text that we pass, it doesn't understand the text like that. So we have to convert it into something that it can understand. So we create vectors out of it. So we create embeddings that are basically float numbers. So, and then with those float numbers, it makes some calculations about cosine similarity and calculates the angle or calculate how close one of these float numbers, these vectors, is close to the other one. So it's a lot of mathematics and a lot of things involved there. But after that, if you see here, let's say that I'm going to write about latte, you will see the probability that the next word will be milk or coffee or tea. Those ones are really close in context and in meaning to what I'm looking for. But car, for example, the probability goes down. Same thing if I'm starting to write pulling into a parking space, you can see that what I'm pulling into a parking space most probably would be a car tire, but chocolate, it would be down below. So it's basically doing those calculations and say, okay, so, but that's just for one word. So what happened for the next one? So basically, actually, we can see it here. Let's go back and let's go to GPT tokenizer.dev. So we see it in action. GPT tokenizer.dev. Okay, right here. And you see that all these letters that we're putting here are getting tokenized. So, and it doesn't exactly, it's not a token, it's not exactly a word. If you see tokenization, have like two tokens here, a dot is just one. So it's really interesting to see like GPT tokenizer with a middle guy. I don't remember the name of that one. So it's like four. See 1, 2, 3, 4, 5, So you can actually see the number that's generated. So this is really interesting to understand what's going on and how that is going through the flow. If you see this flow, you create your prompt, and goes to a tokenizer, it makes that one, send it, encode it, send it to the matrix, make sure that it gets the coding, get the result, and so on. So basically, if you see, for example, this sentence is, and that's the point that we were trying to make before. You say, okay, we need, and we let it there, and we send that to the model and say, hey, complete this. And he say, wait, what is the next word that I'm going to find? Stop. After that, the whole sentence becomes the input again. And we send to the model, we need to stop, and we send that to the model, and it complete another part of another token, and then anthrop, and then send it again, and send it again until you have a complete sentence. And if you can continue as much as you want, as long as you have enough tokens, enough quota, and you have your model running, it's up to you. So you see that you have n tokens in and just one token out, and then you repeat the process, and then you repeat the process. And it's usually fast. You can see now with GPT-4, you write something and you start going and spitting all amount of great content. So that's basically how it works. You say, she went to the store, and basically we find the other token that it will push, that it will fill out later. So use case, there are a lot of use cases. Of course, the biggest one that we see right now is text generation, about helping you write an article, helping you write a blog post, helping you write social media content, marketing, virtual assistants. You can see right now, customer service, translation, language, data analysis, information, classification. Those are really, really great. Great use cases, great practical applications. Like, of course, we would love that it does something like brush your teeth, like wash your dishes, so we can also focus on that, because it helps us a lot right now in writing like creative things, but we would like to help on mundane tasks as well. But now in a more serious note, if we think about this, I was in a conference with Miguel de Casa, and he was mentioning that he had a friend that he was working in a study that there is this type of cancer, for example, where you have to put it in culture, and like for almost a year, and they do a lot of tests until they can find out exactly what type of cancer it is, and with that one they can put the right treatment. In the meantime, they use general spectrum medicine because they need to be like trying to help the patient. With AI, they are able to actually do all the simulation and run it again and train it and redo it and go back. And in 3 weeks, they have the type of cancer, and they know what is the actual medicine. So these are real life applications that you can see. There is another company in California that we're working with that basically is using environmental projects, and they are checking how are the practice to see how much carbon emissions or carbon sequestration, or one of those metrics they are doing. And with that one, they can check other projects and with comparables metrics and give some recommendations to improve the environment. So those are real life applications. So the power that we have right now is immense, and everyone who is not actually trying and thinking of how to put AI in their system will get behind. And that also counts for the SAF work, where all of Linux business application will end up with some type of AI assistant or AI helper. I know that Yama-chan is already using it in the Llama Logger to explain the sections that you're getting and to give you some recommendations about it. So, of course, we cannot talk about AI without mentioning responsible AI and all the things that we need to do, everything that you put in the model. Give me just a second quickly. Let me, because I have a lot of noise here for just 1 minute. I lost all the, right. Sorry, they are doing some work on the backyard beside me, and they were a lot of noise for just a second. All right, really important to mention that what you put on your AI is what you're going to get. So let's say I don't know, that you are doing a hiring algorithm that the AI will help you with the hiring. And basically, we are in your company a lot of Spanish speaking devs, and maybe there is a dev from another part of the world, and the AI basically just not taking into account because it has not been trained with that data. Same thing you have seen with a lot of others. So there is a bias. We need to know how the model has been trained. We need transparency on what the data has been used to train the model. Same thing for equity, for privacy. We need to know that our data is safe if we're sending it to the model. How inclusive is, how sustainability, the collaboration, education. Right now, universities are starting to use that for their tests, for doing trial tests for the students so they can get more and more practice before the actual test and so on. So this is something really important. So keep that in mind when you're building your line of investigation with AI. So we talk about how LLMs are doing all their generation. So what we didn't talk about is like if they are doing it like that, so it's not that smart at all, right? So what it doesn't do? So it doesn't do math. It doesn't know anything about it. If you do asking like 7 plus a number and multiply, like it will not know how to do that because it's actually predicting. He can predict this next number, but it would be wrong. He doesn't know facts, so it doesn't know how much the weather is right now here in Phoenix. So there are a lot of things that it still doesn't know. So definitely you have to double check when you are getting some response from it. Besides that, how do we get the best outcomes out of our models, out of our AI application? So basically, we need to know the prompts. There is actually a whole new field that is prompt engineering, and that's how you give context to the model. You tell them what you want, you tell them what you don't want. There is also the RAG part where we inject our own data, and also we can do fine tuning. Fine tuning is also a bit more involved, but definitely something to keep in mind when you are actually building your AI application. But one thing that I really like as well is function calling. If we think about function calling, the first time that we were actually playing with it, it's a really nice concept because the LLM and your model knows when you register the function and can look for it. It doesn't find the answer that you are asking for. Let's say that I'm asking him to add 2 numbers. Okay, add 25 plus 200. So basically, if I have a function registered that is called addition of numbers, and it will call my own code where with those parameters, the numbers, and I will be able to do the logic myself and send the data back, and it will respond it to you in a like fluent way. So this is really nice. And then also a context, like we need to, like if you go ChatGPT and you see that you're chatting with it and you say at the beginning, hey, remember this, and 3 lines, 3 chats later, you can see that can still remember. That's because they are doing that, but the model actually doesn't know. He does not save in that context. If you're doing in your own application, it's up to you to save that context and actually send it in the next iteration. So let's say that I tell them, hey, my name is Jose, and he will say, okay, and he will find a function that is say, okay, his name is Jose, he has a function to save his data, let's put it in the database. Next time that I ask, hey, what is my name? He will say, okay, let me see, I don't know, but let me see if there's a function that can retrieve that name. And then same thing with the weather. Hey, what is the weather in Phoenix? It will say, I don't know, but let me say if there is a function registered, and it will go and check, okay, yeah, there is one, and we call in our own code. So that's the beauty, the weather API, and we will get what is the weather. So this is what it blew my mind. What about if I ask him, hey, what is the weather of where I live multiplied by 200? So it's smart enough that if you have all the functions registering without doing anything, it will say, okay, wait a minute, who are you? Okay, this is Jose, he told me before. Where do he live? Okay, he lives in Phoenix. Okay, does I know what is the weather in Phoenix? Okay, let me see, there is a function? Yeah, there is a function. Weather in Phoenix is right now really hot, like 90 something degree. And then we say, okay, and I don't know how to add, but there is a function for adding. Yes, okay, multiply that one. So it will take those 3, 4 functions, it will concatenate it, and it will know just by one sentence that I tell him, hey, what is the weather of my city, multiply, and it will give you the right response. So that's how smart they are. So now let's go real quickly into these three topics. First one is prompt engineering. That's the art of giving instruction to get a useful result, basically telling the model, give them some context, basically be simple, be directly what you want with precision. So can you write this article and give the context that is for a magazine that and you can also tell the head you're going to be an assistant helping me to write articles for a university that we're going to talk about stuff and we're going to create one article a week. Can you suggest titles? And you tell them also what you don't know. I don't want to talk about this. If you know something, please just don't. And it's really good to give examples. So you can tell them, this is a type of prompt that I could give you. This is the expected result that I want. And if you do it like that, you have a really high probability that I will tell you exactly, and it will respond exactly what you want. But I always say, so if I knew that prompt engineering will be the art of giving instruction to think what you want, like my mom and my daughter would be engineer already, because they always get what they want when they come and me, and they put those phrases. So that's what it is. Okay, right. Bring your own data. So Azure OpenAI makes it very simple to do that. But basically, the idea here is that we take our own data, let's say, or PDF. Like we have one insurance company that we had them, and they basically took all their claims, all their insurance, and they uploaded to their own system, make embeddings out of it, do the vectorizing, and then every time that they do a prompt, they send whatever is closest to that one, and then you can do things like that. Hey, is my insurance cover ambulance? Or if you do it with your list, if does my list like it's really good and using your data, so you can actually ask questions about it. So you don't have to read those 300 pages that insurance have. So basically, you can see here, basically you take your own data that probably you can put it on blob storage or something, send it to cognitive sets that won't take care of actually vectorizing and doing everything. Then you send it through Azure OpenAI to the model, and from the model, the web application can read it and everything in between. But that's the gist of it. If you think about this, you don't have to do it through Azure. There is a really good data vector engine that has Postgres, or you can even do it in SQL Server. You just save it as a vector and go from there. So fine tuning, I just want to, I'm not going to go deep on that one, but I just want to mention, be careful with it. You can drown because it takes a lot of time, it takes a lot of resources, and sometimes doesn't give you the actual result that you're expecting. You will do fine tuning in the cases that, for example, let's say that you're building an AI that writes like Shakespeare, or that writes like, I don't know, any of your favorite author, or like you want to write to a certain way. So you have to have some certain tone, some certain words, some certain, and then fine tuning, that's what it will do to you, because it will be trained just on that specific domain business design that you have. So now we get to Azure OpenAI, and basically Azure OpenAI for me is the best way right now to create a prototype and right away have your system a prototype that you can say, okay, let's do a chat box, or let's do an assistant, or let's do some completion, or let's do some type of app. Azure OpenAI make it really easy to just go there, select the model, select what is your deployment type, select, give the system user, give the role, and you start playing with it. So you can actually do RAG real fast. So what does it bring? Scalability and performance. They are using the latest of the latest on hardware, security, so you have governance on your data. Really easy to integrate. They actually have a right click, take the code, send it to your app, and access to all the latest model. So right here in the playground, you have what I was mentioning: chat, completions, image deployment, the model, subprompt, and so on. So before going further and going to the actual portal, let's actually run a little bit an application so we can see what we have in here. So let's run here, and then we go back here to the code. So we think that we're gonna start doing. All right, so if you have here, I think that, let's see if the gods of the demo help me. We're gonna ask something. And you see right here, we're starting to build just a sample app that we can integrate to SAF right away. This is just Blazor. But same thing with image, the one that I always like, 3 in palm hand. And if you guys have done anything, just to the message on the chat so we know. So basically, you see right here is here. And there is a lot of more things to it here. So let me, I think that we are in another project actually. Right here. But that easy is to create image, bring it to your app, create chat applications and so on. So if you see here, this is sample API, and right here we get speech from text, get audio transcription, get audio translation, get completion, get chat completion, get embedding, get image generation. So basically you can do anything that you need to do here. And let me try to not share my Azure credentials by mistake. All right. Now, with that out of the box, let's try to see if we can create from scratch an OpenAI. And be careful, as always, if you are playing with it. Let me see. Let's put, so I don't forget to delete it. Create new. Delete layer RG. All right, it's telling me that this is not that it doesn't have access, because right now you have to request access, but I do have access. So that's why I did this. Right. All right. I think that, let me just a second. Jose, are you there?
Yeah.
Right. Do you want to take over while I fix
If
this?
you wanna, yeah, I can take over in the meantime.
Yeah.
So, okay, so it's time for another part of the presentation. Let me share my screen. Let's share this one. Okay, so since the topic today is Azure OpenAI, in the end, what we want to show, like regarding SAF, is that the OpenAI API is kind of the standard for all of the possible API servers for AI. So here I have some articles about LangChain, about Olama, and like things that I use inside of the office in general. But the one that I wanted to show you today is that if you want to do like kind of a really easy integration in your .NET project with large language models, the tool to go, if of course, if you're using .NET, not Python, or something like that, or even if you're using Python in this case, is semantic kernel from Microsoft. So semantic kernel is basically it's an SDK. It would be something like if you have used LangChain, something like LangChain, but the origin of this is .NET, not Python, because LangChain was created for Python originally. So this is kind of the new kid on the block regarding the competition of AI SDKs. So it started like with 17,000 stars in GitHub. So imagine which popular is right now. And right now it's 18,000 stars. And they made like 1 million downloads like not so far ago, like a few weeks ago. And there is also like 25,000 downloads for the extension of semantic kernel. So the idea about this is something like a framework to do integrations with Azure OpenAI compatible APIs. So now that we got this out of the way, what we're going to do today is use semantic kernel connectors and plugins. So the connectors and plugins are basically a connector will be something like I want to connect to OpenAI, or I want to connect to something else. I don't know, like maybe Opus, Cloud Opus. So right now, like I don't have an API key for Azure OpenAI because we kind of had a problem with the key, like just a moment before the meeting. But I can show you the code and implementation. So here we have, this is the demo that I created for today. So hold on, the studio is in a different window. So this is the, what looks really small in this one. Where can I stop it here? Okay. So the idea here is, let me close all these tabs. Let's check who is. Okay, so the idea here is, okay, first we need to integrate the packages from semantic kernel. So that can be really tricky because semantic kernel is a new tool, like it's a new SDK. So some of the nuggets are still in preview mode. So for example, here, this is the semantic kernel that usually you need. This is the core. Then you have the OpenAI connector, which means that it gives you some specific methods to integrate to OpenAI. That can be Azure OpenAI or just OpenAI. Both are kind of the same. I mean, the internal working of each of them is different because there are some constraints on Azure that they don't exist in just the normal API from OpenAI, like privacy policies, for example. So, and then we need the core, and then we need the plugins. And this is kind of the tricky part. Some part of semantic kernel are still in alpha version. So what it means is that they are in active development. So that all the APIs can change at any minute. So don't write any production code with this, at least not right now. And then you have to add this to your project, because if not, it will not allow you to use alpha versions. Because in this class, everything has a warning. If you use it, your code will not compile because it says like, okay, this API is just experimental and it might change in the future. So you need to turn off those static analyzers with this exception. So being saying that, then we have a few classes. This is kind of really simple idea. So we have kernel setup. Semantic kernels create like an engine that you call kernel in the end. That's what you call it. So here we have the information that we need to create a kernel. Usually you need to name a kernel. You need the deployment name is actually the model name. Then the endpoint when it's going to run, and the private key for that endpoint. And then if it's a local kernel, I will show you what this means a little bit later. So that's the kernel information. So then like with this, like it's a local kernel, it means that not necessarily we need to call OpenAI APIs or Azure APIs. Both of them are OpenAI standard, but one is hosted in OpenAI, one is hosted in Azure. So the idea here with this is local kernel is that we can run local models. So what I wanted to show you here is that there are other ways to provide information for the models. For example, we have LM Studio, which is a tool that you can use to download new models, load them in memory, and then do chat competitions with it, or serve them as an API, which is OpenAI compatible. And the same goes for Olama. So in my computer, I'm running both. Here, well, you don't is in another screen, and I cannot move that because it's in the near in the taskbar in the end. I'm running Olama, like locally, and it includes an API server, and also running LM Studio. So in this case, let me clear the logs. So this allows me to run a local server. So in this case, since the API here is not working for me, I'm going to run everything with the local server. So in here, what I want to show you is that in my models, I have few of them. I have the Fit 3. This is the last one from Microsoft. This is kind of really, really fast, and it's small. So it's kind of nice in that sense. See, it was downloaded yesterday. So this is small, 2.32 gigabytes. But in this case, this is not as fast. The fastest one that I know right now is this one, HEMA. So this one is almost as small as Phi, but it's way faster. So for local testing, it's better. Maybe not more accurate, but better in that sense. So here, I basically, the only thing that I did is that I select the model here, and then I just turn on the server. And that will run in basically this URL. And then you can use any OpenAI API compatible code to call this server. So to do that, what I used was the semantic kernel, one of the overloads to create it. So let's check the semantic kernel controller. So in here, we just have a single choice action. What this single choice action do is that when we, on the unactivated first, we go and load all the kernel setup information, whatever that is, right? And then we put it in single choice actions. And then when they pick one, we build a kernel with that information. So when it's not local kernel, the code is like this, which is basically we create an Azure OpenAI computation engine, and on the other case, it's the same, but it's not, see, this is Azure OpenAI, and this is just OpenAI chatbot competition. Both are kind of the same. The thing is that one goes to OpenAI APIs directly, and the other one you can redirect it in any possible way that you want. So for this redirection, what we're using is we are passing the HTTP client with a local model handler. What this handler means is that it will intercept all the requests and forward them to your local server instead of sending them to OpenAI or to Azure OpenAI. So if we go here to definition, this is just a local handler. I have an article about handlers in my blog. So here we're taking the request, we rewrite it and send it to a different place, basically to the URL that I'm passing on the setup. And that's basically it. So let me show you the application running before I go deeper on this. Or maybe no, it was not running already. So in the meantime, let's have some water. Okay, so this is going to be a little bit slow because we are using the local large language model server. And I want to explain you something about it, but let me first go and check the setup. Okay, so here I have the kernel setup. I have two kernels right now. One that should go to Azure OpenAI service, C. So here I have all the information, the deployment name, which is the model, actually, the endpoint, and this is not a local kernel, so, and the API key. And if we check the other one, this is one from LM Studio, the one that I have, that I show you here. And the model that we're going to use, the model is actually ignored in this case. It doesn't use any, it ignores this parameter. And this is the URL that we are going to use. And in this case, LM Studio will answer with the model that is loaded in here. I can eject this model and select a new one, but for this case, I will just leave that one because it's kind of fast in general. So as you can see here, like how much RAM are you using for the model. And this RAM is video memory RAM. So it means it's from your GPU, not from your computer. So this is supposed to be a gaming computer what I have, but the GPU that I have only has like 4 gigabytes of VRAM. So anything that is bigger than that, it will not be loaded in memory. It will be like on disk at that moment, and you will load chunks of it. That will make it way more slower. So the bigger GPU that you have, the better it is, because the more memory you have also in your GPU, it's like you can load bigger models in memory in general. So, okay, so we have these two kernels. And I have two different functionalities here that I want to show you. So first one is we can summarize text. And the other example that we will see is how to just process prompts in general. So let me show you the text summarization. So first, here we have a story about a cat. So the name of the cat is Whiskers. And I want to make summarizations of this text. So what I need to do first is to build a kernel. In this case, I'm going to use the local kernel, not the Azure OpenAI kernel, because the API key is failing for this. So let's do this one. Okay, I have the kernel loaded. Now, let me show you the controller for that. So where is the studio? So we have in the controllers here, summarize controller. This is kind of super simple. So it's a pop-up Windows action that in the customize event, it will basically create a non-persistent object to show a small view with the summarization. And then it will get the loaded kernel from the kernel controller. So when I create the kernel and I select it, I put it in a variable so I can use it out from other controllers. And then what's going to happen is that we have a prompt that we can inject some information. So the prompt is write a summary for the following text. Actually, the prompt that you will use in reality should be more extended, like don't repeat yourself, don't repeat your answer, and things. A lot of things like you have to do little tweaking to make your answer more accurate. So, and then basically to the kernel, we tell it invoke prompt, and then we get the result from it. But let me show you when we build the kernel in the kernel controller. Also, we are adding some plugins. So semantic kernel, it gives you like a pluggable architecture, so you can add more things, either connectors or plugins. But all of these things are now at this moment in alpha. So they say like this can change, and it's changing a lot still. But for the technical demonstration, this is good enough. So as you can see, in both type of kernels, in remote kernels and local kernels, I do the same. I add the conversation summary plugin. This will process the prompt in a different way. So let's go to the summarize controller. So in here, I just get the text that I want to summarize. I pass it to the kernel, and then I wait for the answer. So let's do, I will put this one here. And the other one that I need is LM Studio here. So let's see if we can which one we can make smaller. Let's do it like this. Okay, and as you can see, there are no logs here. So if I click the show document summary, now it's going to be start being processed. And here you can see it received the prompt and everything. And now we'll start, see, now it's using CPU. And see, here is producing the tokens. I will just make this bigger. So here's generating all the tokens to basically calculate the answer. Since I'm not, you can actually stream this. And by stream, I mean you can write word by word into your control. But for the sake of the example, I make it just easier. And it's like, I will wait for the complete answer and then put it in the pop-up window. So right now, see, it's using 32% of my CPU. So it kind of uses a lot of resources. So let's see how my computer is doing actually. See the CPU, how it is growing, and also the memory. So, but, and let's see, and also the GPU, I'm using the GPU here, but one of them. The second one I'm not using at all. So I guess it will depend on which GPU are you running your model. So, okay, here it finished. And now here we have the summary. Here's the summary, Whiskers and Adventure Cat, blah, 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 blah. So here we have it, and it was kind of really fast, right? So you can do that with whatever text you want. So let's click OK here. And the second text that I have is something way more complex. So the second text is, what is XAF? So for that, I use an article that they have published, like where all the MVPs are like talking about XAF. So this one is way longer. See, so it will take way more time. So let's try to do it anyway. Let's show summary. Okay, I need to select the kernel, studio. So right now, it's computing again. As you can hear, you can see here the prompt. And it's not, well, I think it's just started, yeah. So now it's generating the summary for the key parts of that document that I pass. I mean, how to parse the document, if it's a PDF, if it's a Word document, it's up to you. You have to decide how to extract the text from that and pass it to the kernel. But in most cases, that as a programmer should be a trivial thing for you. What I want to show is the integration with the OpenAI API compatible servers. So here it will take more time because this, of course, is a bigger text. If you do this with Azure OpenAI, it will be like extremely fast. For example, we did another talk on Saturday with Javier, and I showed the example on why sometimes local models are not a good idea, because we asked the large language model to write a recipe for tacos al pastor, which is kind of my favorite food. So if you send it to Azure OpenAI, well, like, okay, if you do it locally, depending on your model, it will be like 1 minute to give you the whole recipe. But if you send it to Azure OpenAI, it will answer in around 3 seconds. So it's a huge difference between 1.5 minutes or almost 2 minutes and 3 seconds. So here, see, it's still taking time, but this answer will be a little bit big, I would say. So let's wait a little bit, and then I have like just another small demo. Well, while we wait, I can show you the code. So, oh, it's done. So here's the summary of what XAF is, based on that document that I put there. So the second part that I have is like, I mean, once you have the kernel, you can basically use any of the functionality that the kernel has. So you can just do prompting. So you can write here, for example, what is an application framework? And let's select the kernel for this, and then studio, and then process the prompt. and now it's generating the tokens, and we're waiting for the full answer. So this controller is kind of really simple. If I go here and I go to the prompt controller, it's kind of the same idea. I have a simple action. In the simple action, I get the kernel controller, I get the variable for the kernel, and then I invoke the prompt, the text that I wrote in the upper part, and then I will wait for this to be processed, and then I return the result. Usually the thing that you need to do to show the customer that something is happening is do streaming, like take word by word, so he feels like something is answering you. But in this case, for simplicity, I did it this way, like just waiting for the full answer. Let's see, still, I should have tell me what an application framework is in 200 words, or like with some limitations. So that's the important thing about prompting, right? If you don't do it right, something like this can happen. Well, but it's doing fine. I mean, I guess it's about to end. He's doing examples right now, and in here, since we are using calls to the local server, the only thing that is important, because I kind of know that the local servers are slow, in the kernel setup, when I create the HTTP client, I pass it a timeout of 10 minutes, because it can take, I have some cases that the answer takes 5 minutes. Of course, it's because it's a local model. If you use an API, it will be way faster. So let's see how the answer is doing. Still explaining me what is an application framework. Like if I don't know. Okay, let's wait. Oh, it's done. So this is what an application framework is. It's a software collection and set of tools that provide consistent, reliable, scalable approach to building, deployment, and maintaining applications. So as you can see, it's kind of a really interesting idea. Nikita is asking for the recordings. Yes, they are in Javier's YouTube channel. You can also check them in the Facebook group. We post them afterwards. So you can go to the, I guess someone can post there like the address of the Facebook group. If not, I will post it like before I finish. So this is kind of the idea. As you can see, semantic kernel is a really good tool to do OpenAI integrations or OpenAI compatible integrations, in the sense that you can query any other model. You don't have to use Azure in this case. You can use it also with LM Studio, as I'm showing here. It will depend a lot on your hardware capabilities. I have MacBook Air M2, which will process this like way faster than this one. So it depends on basically your type of computer. But it's also good to do local tests, even though they're kind of slow somehow. So, well, that's everything for my demonstration today. It was short, but I will be including more complex scenarios with this solution. And when it's ready to publish, I will put it on, well, it's on GitHub already, but it's private at the moment. So that's everything for my side, Javier.
And that's it. I think, Oche, we're going to follow up with a small video about all the settings of Azure OpenAI. Incredible as it seems, I deleted the whole resource group with everything that we have done just to start from scratch and show everything here. And now, because Azure AI right now is still in a request base, now when I try to create the new one, it tells me that I have to re-request. So some things that happen sometimes in my subscription, but I can fix it. I'll do a small video to follow up here and enjoy it. Either way, I will, when we post this video, if the other one is still not up, I will post the link with the actual time excerpt of the Azure configuration that we did in the other talk of Global Azure. So that will be there as well. All right. Everyone, as always, thank you for coming. We really enjoyed talking about XAF, Blazor, XPO, and the framework, and now
AI now.
So thanks for always sticking with us, and see you next month.
Okay, see you.